Hello everyone. In this exercise of SolidWorks, we will study the displacement or deflection in a cantilever type beam. Okay, let's start. File, new, part. Part is the default template. There are the three environments: part, assembly, drawing environment. Part is default environment. Select OK. This is the SolidWorks user interface. Okay. Command manager, menu. This is the menu bar. This is the tab section. This is the view head-up tool. Okay. This is the future tree manager. This is the task pane. This is the task pane. Okay. I am selecting the background plain white, and unit system is the millimeter gram second. Okay. Now I am selecting the front plane. Okay. We will study the deflection or displacement in a cantilever type beam, cantilever beam. Okay, cantilever is just, you must have seen in the construction industry, there is one part of the fixed, another is the open free end. I am taking front plane, this one, and I am drawing a line here. Okay. This one. This dimension I am taking 600. You can take as per your requirement. You want to know the deflection in the simulation, and this one. Now weldment. Weldment, we will create a pipe in a circular pipe in weldment structure. Weldment first out of the sketch, and weldment structure member. I am taking this, selecting the standard ISO pipe. This is the pipe 33.74 mm thickness group, and I am taking this one. This is a pipe. Okay, but I want to change the size so that you could change the sketch in the standard weldment structure. Okay, so this is the pipe. Circular pipe 33.7 into 4 mm thickness. This is the sketch. This one, edit sketch. You will see our size is 30, outer dia is 33.70 and inner dia is this one. Suppose I want to increase this one. I am taking suppose 50 mm. Okay, and this dia I am taking 40 mm. This one. Size changes, the size changes, and this one. In this way, you can edit the sketch in the weldment structure. Okay, this one. This one. This is the pipe. Hide this sketch. Right click and hide this so that model is clearly visible. Okay. Now we want to study the displacement or deflection in the cantilever beam. Also, we will calculate the factor of safety and see the stress analysis. We also see. There is a simulation tab. This is the tab section. There is simulation tab. If you don't have the simulation tab in your tab section, you can go from here and add-ins, and there is you will see SolidWorks simulation. You check it and OK it. Then it will appear in this tab section. Okay, I am clicking simulation, new study and simulation advisor. Simulation advisor advises the new user how to go ahead for the simulation study. Okay, but I know the setup, so I am clicking new study. You can give the name of the static study. Whatever name you want to give, you can give static to, suppose, for example, you can static tube. Okay, this you can give it name. Whatever you can give. Now, first in the simulation, first we have to prepare the model, which I have made it. Now, next step is the cut list. Cut list, there is a pipe. Right click, applied. Now I am applying the material. Whatever material you want to select, you can select. For the required study. I am selecting AISI 30, that is a stainless steel. This one, apply, here is a yield strength is this one, and tensile strength is. We are mainly concerned with these data. Apply, close, right? We have done two things we have done. One is the, we have made the model and named the study and the material we have applied. Next is the connection. Connection is used in the assembly when we have more than one part. We will study in the coming videos for this type of assembly. Fixture right click, fix geometry. Fix geometry. In the simulation, static simulation, we fix certain part of the structure so that it could not move. That's why it is known as the static study. So I am selecting this portion. These are the joints. I am fixing it. If you are not clearly this is visible, you can go in the symbol setting and you can increase the size to, for example, 250. This one size increases. This part I have is a joint I have fixed. Okay. Now external load. Now I will apply the load here. Force joint. This is another joint. I am applying on this joint, applying the force here. And this one, you will see, if I bring my cursor here, you will see the option face as plane or projection for the direction purpose. Click it and you select this direction, front plane. This is the direction. Unit system, I am taking SI. Force from here I am taking 3. Suppose, for example, I am taking 300 Newton. Okay. And symbol, you can increase the size of the symbol. Suppose I take 300. This one. But you are saying that force is from vertically from downward to upside. But you will see this is the forces. But I want to change the direction. Force reverse direction. You can reverse from here. So I want to apply the force from vertically downward direction. Okay, this one. Now I have applied the force. Okay, mesh. Right click, create mesh. This one. Mesh has been applied. In this way, for the stress analysis, my model is uniformly distributed in the finite elements of the specific size. Okay, in this way, uniformly distributed in the finite element size. And now in the command manager, you will see results advisor. You can click it and result advisor. Sorry, run this study. Run this study. Now run this study. Study is done. Calculation has taken place. Okay. This is the color chart. Okay, this is you can displace it here from proper position. This is the color chart, and now we will study. This is the stress and stress. You will see stresses. You can see from here. This our yield strength. Yield strength is what? Yield strength is that strength. If the load is applied up to this load is applied on this part, the part will not fail and deformation will not take place. This is the safe value. Yield strength is 2.06 into e raised to the power 10 raised to the power 8. Okay, this is that value. The component doesn't fail. Component bear this load without failure. Okay, this is the yield strength. Now strength, this one you want to animate it. This one you can see the grade stress are at a use, but the deformation scale is 94.596. Okay, this one from here you can increase the speed, decrease the speed. You will see this is the speed, you can control it, and this one you can frame rate you can increase from here. Suppose 25 frame rate for the smooth operation of this thing. You can start it from here. You can save also as AVI file, this one. But this is at this scale, 94 scale, that is elevated scale. But Up, if I want to know the chart option, you go from here, chart option, maximum and minimum, and edit definition. You can change the here from the units, Newton per millimeter square megapascal. 1 Newton per millimeter square is equal to 1 megapascal. Okay, automatic you are seeing this is the deflection is showing at a 94 scale, but I want to know the true scale. This is the true scale, actual scale. User defined, suppose customer want to see the analysis at his level, so you can assign the value as per customer choice, then he can see what is displacement or stresses are showing. Okay, but I want to know the true scale, actual scale. This one, this is the stress. This is the maximum and minimum stress you can find out from it. You can also find out that, suppose you right click and this is the one is probe. Suppose you want to know the stress at this point, the data will show here. This value is this one. Suppose you want to know the stress from this point, the value is showing this one. So at any point you can check the value, just right click and click. So the data shows okay, the stress at this point is this one and this one. Okay, but our product is safe because yield strength value and the red zone is a maximum stress, that is 2.48 into e raised to 10 raised to power. This value is less than this one. Okay, so this stress is our product is safe. Okay, now displacement, double click on this one. Now this is the displacement. This is 6 maximum displacement, red zone 6.3 into 10 raised to power minus 1. It means 6.34 3 divided by 10, that is 0.6, very less. Okay, suppose I want to this is the minimum 1.00 into e 10 raised to power minus 30, that is very less. Okay, suppose right click, chart option, scale is 294, maximum you can maximum displacement, minimum displacement you can show here. You can here change the decimal value. You can change here from bottom side, this one you can change the decimal, and definition you can take the true scale, this one. This is the displacement. Suppose you want to animate it, you can animate it, this one. So this is very less value. Okay, 6.3, 4 into 10 raised to power minus 1. Suppose you want to calculate 6.34, 6.343, 3 divided by 10. E raised to power minus 0.1 means 10 raised to power minus 0.1 divided by 10. This 0.63, that is very less displacement. Okay, and you can increase the speed from here. This one, this is the speed, and you can control the frame rate from here. You can start it. You can save the AVI file also. Okay, in this way you can save this thing. This is the displacement. You can show the displacement also. Okay, and this is the simulation option. You can also plot subtitle. Suppose this is the you can go in the simulation option, and there is you see subsystem option or default option. There are three things: plot title, plot subtitle, and color chart. You can change the color of the chart. Suppose you want color of the chart, you want to change the font, italic, etc. You can change from here. And you point the plot subtitle. This is the you can change the this is the plot subtitle. This is left hand top side. This is the plot subtitle. You want to change the font and this one, and decrease the size or increase the size is okay. This one, this increases. This is the plot subtitle. You can change also. You customize this thing. And color chart also I have explained. Simulation option from here. This one. Color chart you can also this one. Okay, you can even change the color of the display look color chart background. Suppose you want to change the color, this one, color chart, this one, this. Suppose you want to change the yellow, this one, okay, and this one. You can change the color of this thing. In this way, you can change the color of this one also. Okay, this is the displacement side. Now, factor of safety. If you want to know the factor of safety, how we will calculate? You go in this thing, result advisor, new plot, and factor of safety. This one. Click this left hand side arrow button, this one, and now this one. This is the factor of safety 8.3. Our factor of safety is 8.3. This one, maximum this one. Okay, it means factor of safety must be equal to more than 1. For the safe value, it should be 1, but suppose factor of safety is 1. It means product is safe. Okay, but it's not okay. It is safe. It can, under the applied load, will not deform. But factor of safety must be more than 1. It means if it has 8.3, it means it is suppose I calculated 8.3. I have applied the force 300 Newton. This one. It means product can bear this load without deformation. This is the mean of factor of safety. Factor of safety into applied load. This one. It means this this part can bear this much load without deformation. In this way, you can calculate this thing. This is the factor of safety. Okay, I hope you would have enjoyed this exercise. You please like, share, and subscribe this channel. Thank you very much.